Hello friends, welcome to our channel. In this lecture, I would like to explain analysis and design of a beam by using Staadpro Connect Edition. So this is the user interface of the Staadpro Connect Edition. So here select new. In that you can choose file name whatever you want. So I will explain model 1 like that. I will take the name of model 1 or beam, any name. Then I will store my default location in G. If you want, you can store wherever you want, and here I will choose metric in terms of kilonewton like that. And so select the analytical option. There will be three modes: physical, building, analytical. So first you can select analytical and then go create. So after selecting the create option, then you can see this type of interface here. So here again in the geometry you can select the grids option. There you will get some default grids: beam grid, triangular plate grid, quad plate grid and solid grid. Here you can select beam grid. So after selecting the beam grid, so the default grid will be appears like this, which is beam grid. So this is in 2D direction, which is x and y direction. So for knowing the properties of the grid, first you can go for the edit option. So this is the toolbar for that particular grid. So here you can edit that one and see the properties, or what are the properties it consists. So it will be in xy plane. If you want, you can change into xz like in 3D plane and yz. So whatever the plane you want, you can choose according. By default it will be in xy plane, and here grid origin will be at 0 0 0, means each and every time it will be starts from 0th node only. If you want from x part, you can take some 3 meters distance, means you can keep 3 here. If you want to change in y direction, you can change here like that. You can read the plane, and here y1 plane in 0 degrees. If you want, you can kept angle of plane of some 45 degrees, means you can apply here 45. You will get by default 45 degrees like this. So whatever the properties you want, you can change according to your design. Okay, then if you see one more thing, again here, again x and at x point and y point, it will be starts from the 0th node, and there will be 10 grids in the right side, which is in the x direction, and there will be 10 grids in the y direction. So each and every grid consists of 1 meter. Sometimes if you are designing a beam of some 15 to 20 meters, so here there will be only 10 meters and each grid consists of 1 meter. At that time you can increase the grid 1.5 meters and right side some 15 like that also. So you can change the grid according to your design. So here the properties, and in y direction also I will increase some 1 meter grid, 15 meters like that. Okay, like that you can change the properties. Then after changing your properties according to your design, then I will keep the node here at the 0th node, and I will draw on this grid only. So I will draw a continuous beam of 6 meter span 1, and the next will be another 4.5 meters, which is 10.5 like that, and the next one more will be some 4 to 5 meters. So up to 18 meters I will take. So this is a continuous beam. We will discuss on that beam. So like that only, if you see here, after drawing again you will see the cursor like this. So if you want escape from that mode, please press escape button here. Automatically whatever the option you are, automatically you can come out from that option. Then here there will be highlighted in the dialog, so one small cursor you are observing here, tick mark. So if you off this one, automatically your girder will be disappears. If you want to see the grid again, means you can click that option on. Otherwise here you can highlight that option beam grid, or else in the geometry you can switch on here by clicking the same beam grid option, or switch off here. So this is the grid option. And again in the view section, see there will be various views. This is the isometric view which is in the 3D view, and again this is the top view, this is the bottom view, and this is the left view. Like that, whatever the view you want, you can choose according to your convenient. Here I will choose front view. Okay, so this is the front view of my beam, and already I created nodes including beams. And one more thing what you want to know here means, in the select option, see here there will be 4 options: node cursor, beam cursor, plate cursor, and solid cursor. For example, if I want to give supports to that particular nodes, so I will select only node through node cursor only. For example, if I am highlighting this beam, so there is only beam will be highlighting. If I am highlighting nodes, so no nodes will be highlighting here. Why? Because I am in the beam cursor option. If you see here there is node cursor, I will select the node cursor option, and then I will select the entire nodes, means automatically your nodes will be highlighted. If I am in the beam option, and then I will select the entire beam, then only beams will be highlighted here. Means the purpose of the node cursor is used to select the nodes only. The purpose of the beam cursor is used to select beams only. But here the purpose of plate cursor is used to select the plates. But here we are designed only beams and nodes here. And the purpose of solid cursor is only to select the solid part. But what is the purpose of this geometry cursor? The purpose of geometry cursor includes to select any item on the frame. For example, there will be combination of beams and nodes. If I use geometry cursor and I will select entire beam, so both nodes and beams will be highlighted here. So that is the purpose of the geometric cursor. So remember that one. Node cursor is used to select only nodes, beam cursor is used to select only beams, but the purpose of geometry cursor is to select entire structure. Then after knowing these points, then go for the next step, which is the supports. Okay, so I will select the supports here in this tab. So again you will get one dialog box. So this is supports whole structure. So you can create the support, select the create option. Okay, if you select create option, again you will get one dialog box like this. Then there will be fixed supports and pinned supports. So first discuss only these two basic supports. So first I will select one fixed support and I will add here, if you visible the fixed support here, and again I will select create, and again I will choose pinned, which is hinged support, and again I will select by default add. Then there will be two supports, one will be fixed support, another will be hinged support. Then I will choose fixed support here. Then if you observe here, if you click assign to view option, then the fixed support will be assigned to all the nodes. So don't choose that option. Why? Because if you want to give fixed support to the entire structure, then only you can choose that option. If I want to give fixed support to the particular end, at that time only you can choose that particular node. For example, if you see here in the view, in the select, I will select node cursor and I will highlight the node here. Then automatically you can see here assign to selected nodes will be highlighted, because I chosen that particular node. For that node only the fixed support will be visible. So then I will assign from this method. So there will be fixed support assigned here, and again I will select one more support here and I will choose support 2, and here again if I am choosing use cursor to assign, means again I can see where the node point will be. Again I will highlight the node, and again I will choose use cursor to assign, and then assign like this. With the cursor I am assigning like this, and again I will select the node cursor to highlight that particular node, and again use cursor to assign, and again I will assign like this. So like this there will be options. Before only you can highlight this cursor and again selected assign to selected node, means then it will be assign automatically. So there will be 4 options. So this is assign to edit list is whatever you assign, you can edit that one and you can change that support. If you choose this assign to option, means whatever the support you take, it can be assigned by default without selection of the node and without using the cursor. Okay, so that is the different properties here for assigning the supports. After assigning the supports, Again you can go for the properties, means each and every beam we have to mention the property. So whether it will be rectangle, you can select some 400 mm by 300 mm. We know by default the property will be must. After the loads, immediately you can go for the property. So the properties will be assigned to the geometry, then select the property. So after selecting the property, again there will be various option. For example, here define option will be there. The define is only for the first set the define. So here whenever I will choose define, so we have to define the property. Okay, then there will be so many options: circular, T, trapezoidal, general, tapered I, tapered U, assign profile. So we know there will be no circular columns. We have to design only circular, rectangular or square beams only. But for columns we can keep circular also in the portico side for good appearance. But T and trapezoidal, sometimes we are preferring for large bridges, but we are in the starting stage. We can see how the rectangular or square beams will be. So if you choose rectangular, again you will get one image like this, and the material will be by default it will be concrete. If there will be no concrete, means you can choose concrete only. Okay, then in the y direction I will take some 400 in 400 mm or 5 mm. So you can choose here either 400 mm means 0.4. Why? Because it is in meters. In z direction it will be some 0.3 like that. Okay, then add the beam. Here I am not talking about singly or doubly reinforced section. We know the conditions while designing of the RCC. If the depth is greater than some mu greater than mu limit, at the time only you will get a doubly reinforced section. We are not designing that part. The Staadpro by default it will take whatever the design they want. Finally we will see, we will choose this property in the trial sections. Okay, then after click add, then close this one, then you can assign. So here if you want different properties for different beams, for example there will be fixed to this particular span, I will choose this much, and for next span I will choose some other property like 0 some 4.5 to 0.35. I can choose sideways. But for the first problem you can go for simple design, then only you can understand the clear concept up to the end. So I will select this one, and here I will use assign to view. Already I told assign to view option how it works in the support. So just to choose assign to view and assign this one. So by default it will assign to the entire beam. If you see assign to view, I just select assign to view means entire beam it will be highlighted. If you want you can cross check in the view option, again in the view 3D rendering view. So 3D rendering view means whatever the properties you assigned, it will be appeared in terms of the 3D mode. For example, see here it will be 0.3 and y direction will be some 0.4. By default it will be like that. You can check in 3D rendering mode whether it will be assigned or not. Later after supports and after properties, then immediately go for the loading condition. Again you learn the loading topic here. So in the loading, again you will get definitions, load case details, load envelopes. So select load case details here and add. So here if you select load case details and you are going for add option, first you can select dead load. So we know each and every time we are preferring dead loads of the beam. So dead load will be based on property B into D into 1 into its unit weight of the RCC. And again for load case 1 I am choosing giving the name dead load, or else you can keep the same name like that load case 1 also, no problem, it is your wish. And again I am adding here, and again load case details I will add here. Again in the next option I will go with live load. Okay, again if you want you can change the name live load or LL or whatever the name you want, or else you can keep by default load case 2 like that also, it is your wish. Then after adding like dead load and live load, again in the dead load you can add other properties. If you select the dead load and add, so by default self weight load will be visible like this. See here we know if I select X means the load will be acting on the column towards right or left. In the Z means the load will be acting in the columns towards right or left. Y means we can applying the load on the beam, and this -1 indicates downward direction, and factor 1 equal to self weight of the load means whatever the property you are giving. For example, I am giving the property of 400 by 300 mm means 400 by 300 into 1 into its unit weight. By default Staad will be taken that factor here. That is the reason we are considering -1, and minus indicates the load due to downward direction. and 1 indicates self weight of the load, whatever the things by default it will be here, and I am just adding here and close. And again in the live load you can add one more property. Here there will be various loads. Here in the member load I will just go for the member load. Here in the member load again I will choose the load. So I told that minus indicates the load acting towards downward direction, and I will keep some 20 kilonewton per meter. For example, if I will keep this distance, so the load will be acting, for example, on a 6-meter span. If I want middle 2 to 4 distance UDL means I will take some D1 will be equal to some 2 meters and D2 will be equal to some 4 meters, means the UDL will be acting on that particular range. If I am keeping this D1, D2, D3 0 means the UDL will be acting on entire particular member, not on the beam. I will show you that point also. Just I am going, and again here choose by default global y direction only. GY indicates global y direction, and y direction means we are applying the loads towards y direction downwards, negative. Okay, add, close. If you see here in the unit direction you are applying one load for any particular member, and again I will add one more member. Here again in the member load I will select minus 25 kilonewton per meter global y direction without assigning any distances here, means you will see the difference how it will be added. And again for one more member I will take some another load which is concentrated force. I will take here, we are seeing this type of loads generally in the member load, concentrated force. Again here I am taking minus some 35 kilonewton or 30 kilonewton load, and again here if I will choose D1 distance means, for example in a 5-meter span if I will keep D1 will be 2 means it will be acting eccentrically 2 by 3 meters. If I am choosing 0 means I am not keeping any value means it will be acting exactly at the center. If you want eccentric load then only you can prefer this one, and by default it will be global y direction. Add and close here. So first you can assign self weight of the structure for the entire beam. Again you can use assign to view option, then only it will appear for the entire beam. So assign to view, so the entire beam will be highlighted, means it indicates the self weight will be assigned for total beam. And again I will choose uniform load only for 2 to 4 meters distance, and I will select that beam, and I will use that particular beam I highlighted. Whenever I will highlighted that particular beam, assign to selected beams will option will be appear, and I will select that one and I will assign to that particular beam. If you see finally the loading diagram, so the UDL will be acting on a 6-meter span, 2 meters, and again the beam will be 2 meters, and again by this side it will be 2 meters, like that. And again I am applying here, and I will choose another beam, and I will keep assign to selected beams option. So if you observe assign to selected beams, so here what is the difference? Here in the first beam I will selected the range of that particular span. In the second beam I am not selecting the range. By default I will choose as D1, D2, D3 will be 0. Therefore UDL will be appeared on the entire beam. Here in the first beam what I choose means I will choose as the distance here. Here you clearly observe the difference, 2 and 4. Therefore like that only the load will be appears here. And again for this beam again I am selecting this beam, and again assign to selected beams. So automatically the concentrated force will be acting on the beam at the center point. If you want you can check by using edit option. After applying the loads and your analysis will be completed. First step is to give the supports to the beam. Next step is to add property to the beam. Next step is to add loadings to the beam. Then you can go for the analysis command here, and here you have to define this analysis command, and here you can take, if you want, actually we are not taking any print, you can keep like no print also. If you want any print you can select all and add here and close this one. After analyzing the commands you can go for the run analysis option here, then you can save the structure. You see if there will be any errors are there in the beam or not. So actually it will be in the processing. See, it will be appearing. So it will take some time. So there will be 0 errors and 0 warnings because we are following one systematic format. Then only you will get 0 warnings and 0 errors. Then close this one. Then go for the design. So analysis part will be completed. If you want to choose design part, immediately you can select design here. Okay. After choosing design here, by default it will be steel. So you can choose concrete here. Okay, and again concrete, you can come here, then you can select Indian standard 456. By default it will be in the Asia version. Okay, so you can choose design and concrete and again IS 456. Again you can select parameters here. So what are the parameters generally we are taking in the design purpose? M20 grade concrete, M25 grade concrete, like that we are selecting, and minimum reinforcement and shear reinforcement. These are the three main conditions we have to remember before going to the design. So here, see here, compressive strength of concrete. I will choose compressive strength of the concrete, and again yield strength of the main reinforcement. Fi equal to 415 HD bars or 500 HD bars, and secondary strength for shear reinforcement. And again I will select these three parameters. Don't take minimum and maximum bars. By default Staad only chooses. If you have particular idea for a beam, 12 number of bars will be selected. If you keep minimum bar will be some 12, maximum will be some 16. So sometimes on a beam you can place only 6 bars in a row, but it will not suit at that area of the steel, means maybe it will be difficult. So give the option to the Staad only. How much it they want, it will takes by their own. Okay, then click OK here. After selecting the parameters, the same things you can see in the defined parameters tab. See here, whatever the things we are chosen there, the same things will be appear here. And again we are choosing first value is FC, characteristic compressive strength of the concrete. We know there will be so many grades of concrete, so the minimum least value we are taking for design purpose is M20 concrete if no value is given. Otherwise you can choose whatever the design you want. I am choosing M25 grade concrete, which is 25, and generally it will be in terms of Newton per meter cube, but we are taking meter square, means kilonewton per meter square, means we are taking 25 into 1000. Okay, I am adding here. Then Fi mean 415,000 kilonewton per meter square, means Newton per meter square, means here it will be kilonewton per meter square. So I am choosing 415 in 1000, adding, and secondary reinforcement. So we know that mild steel bars are coming from 250, which is 6 dia bars. If you are choosing 415 dia bars, you will get stirrups starting from HOSD bars of 8 dia. Okay, then I will take again 415 only. Whatever the value you can take, either yield or mild steel, and add here. Then go for the commands position. Okay, commands position. First you can apply, you can, if you want to apply means you can apply, or else you can go for commands position also. Then here we are designing design beam only. For example, we are designing frame. Frame consists of both beams and columns. Then you can select both beam and column. For example, if you are designing any building, so building consists of beam, column and slab, then you can take down slab also. But here we are designing only beam, therefore I am adding beam. Immediately you can take off each and everything. Take off for beam. For example, if you are designing frame, means you can select design beam, design column and take off. If you are designing building, means you can take design beam, design column and design slab and take off, like that you can take. So here we taken all the values, and our next step is you can assign each and everything. So characteristic compressive strength of the concrete will be assigned for the entire beam. So therefore I am selecting this one, and I am choosing the option of assign to view. Whenever I will choose the option of assign to view, it will be assigned for entire beam. Okay, so again Fi main. So here I will go for other option. I will select the entire beam. Okay, then automatically here it will be assigned, that assign to selected beams. Then I will assign here, like that also you can assign. And Fi secondary yield also I am assigning for entire beam, which is assigned to view or assigned to selected beams. And again design beam is for entire beam only. For example, if there will be frame means design beam can be selected only for the beams. There will be columns means design column will be selected only for the design columns. Okay, then assign to view. So if after that your concrete takeoff will be completed, then again you can go for analysis immediately and define commands. Same option again, you can select anyone, add, close. After perform analysis over, then immediately you can run the analysis. Don't run analysis first. First analyze these commands, then only you can go for run analysis. Otherwise you get errors. If you choose again 0 errors and 0 warnings, you can do a particular process like this, you won't get any errors and warnings. For example, you choose some loading conditions will be unparalleled way. First you are applying loading and then you are applying property, you will get warnings. Consecutive analysis are done means you are not doing in a proper procedure. So after obtaining this one, then check for bending, shear, all the values. Then immediately for checking all these values, go for post processing mode. Here in the left side workflow table, check for post processing. If you choose this post processing, then there will be one dialog box will appear. By default you can select OK, and here again you can see force in x direction, force in y direction, force in direction, which is shear forces. If you click shear force, automatically shear force will be appear here. So there will be the tabular formats which shows the each and every detailed points of that particular forces. But I am closing here, just I am observing the beams. See here, this is the shear force. Okay, and again I am closing that one, and I am going for the movement in y direction, movement in z direction. See here how the movement will be. So there will be some minimal movement only, that's why here the movement is not appearing. Okay, so we will check with the option of force in y direction, which is somewhat maximum. And for that, how you can see the values here? For that you can see here annotate. Annotate is the option which is used to see the values. And again here I am choosing beam results. For example, here in the topic of beams, I am talking maximum moments. If you want end moments, you can take end moments. If you want midpoint moments, you can select midpoint, but don't select all. Just for seeing purpose you can check any one option, otherwise it will be clumsy. For bending also I will take some maximum moments and end moments, and I will give annotate option. If you see what it will be appear, end moments also, end force also appearing, maximum moments also appearing on a particular node. For this point there will be two nodes, one will be end and maximum. Like that you can select the see the values also. For example, if I am closing the shear force and again I am checking the moments, so for moments also you will get all the values, whether in the x direction or in the y direction it will be appearing. Okay, so if you want the force in z direction, you can see here like that only. And again you can see the beam in anyway. So if you want to go for check the concrete design, so what you have to do means again you can go for analytical mode, and then you can double click on that particular area. So actually we are generally in the post processing mode for checking all the results like force in x direction, y direction, z direction. Again if I want to see the concrete design, so immediately go to the analytical mode. Then in the analytical mode again double click that beam, any beam you want what, and again here in the concrete design if you see, so the diagram will be appearing like this. So see here there will be top, so top bars will be 4 bars of 10 diameters at a spacing of 365 mm to 400. So by default generally we are calculating 0.75 times of d, but we are providing the spacing of some around based on that range, bar to bar distance. For example, stirrups if you see, we are producing 8 bars, sorry 8 dia bar at a spacing center to center 270 mm. So which is spacing less than 300, we know that a condition 0.75 times of d after calculation of the SV, and again 300 mm whichever is less, like that. And again bottom reinforcement you can see here 3 bars of 10 dia and the spacing is 35 to some 6000. So based on the bar, for example we are choosing 300 mm bar, we are keeping equal distance generally after removing the cover. Okay, so this is the detailing of that particular beam. So you can, if you want, you can see the deflection, shear, bending also you will get directly here only, loadings and all the property, whatever the things you want, each and everything will be there. If I want to choose this last bar details, again I will choose this last bar and I will take the properties of that last bar. So this is the procedure how to analyze and design of the beam and how to take the concrete design. At the same time, after analyzing the beam, after analyzing the beam, you also get Staad output file. In that again you will get some detailing. So here you can go for view output file. See here, if you see that output file, there will be some more details like how much the area of the steel. So this is the Staad output file. If you see here, the design will be starts from here. All the things will be there in the output file. So if I am choosing some concrete design directly, it will goes there, start of concrete design. So we are choosing FC characteristic compressive strength of 25,000, 415 main and 450 secondary, design beam 1 to 3 beams, and again, so here top reinforcement will be 245 in terms of square meter, bottom will be around some 224 square meters, and again section, each and everything will be there here. If you see how top reinforcement will be provided, 4 bars of 10 dia, and again 3 bars of 10 dia, 3 bars of 10 dia. The Staad will be given approximate values for each and every beam. If you see here, 8 bars the area of the steel will be this much, 10 bars the area of the steel will be this much. For example, if you want to calculate by your own, so take down this area of the steel 986, okay, or else you can take down 10 dia bar. So where we can keep 10 dia bar, top and bottom reinforcement, you can take down the 10 dia bar of 686 reinforcement. So area of the steel will be 686. Then you can calculate n number of bars. Based on that you can provide bars by your own manually. You just take down this area of the steel and you can provide manually. In what way we are designing manual designs in the RCC, like that also you can provide if you are not feeling sufficient whatever the design given by Staad. So some approximate values it will be given. So at that time you can take the area of the steel here and then you can go for some projects you can do manually like this also. This is a procedure for analyzing and design of the beam. I hope you understand this lecture.
Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.